Hi everyone, today we're going to be looking at the Productivity 2000 series PLC Modbus TCP Ethernet. The Productivity 2000 series of PLCs have 5 built-in communication ports for easy connectivity to your PC or various industrial networks. Ethernet protocols like Modbus TCP can be utilized with the RJ45 port on this PLC. Modbus TCP is an open published protocol that uses a server or master to client-slave architecture. It's a very common protocol used in industrial automation controls. We will be using the RJ45 or Ethernet port to communicate to a Click PLC. Modbus TCP will be the protocol used on this Ethernet communication media. The Productivity 2000 PLC will be the server and the Click PLC will be the client. We will be creating a network between the two PLCs. A heartbeat will be used so if communications are lost, the server or slave will know. The throughput time will be timed using a small Click PLC program. You will soon see how the Productivity series of PLCs best handles communication with other devices. Let's get started. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in this series as well. Productivity Click PLC System Configuration. We will read and write 10 16-bit registers each, to and from the Click PLC from our Productivity 2000 PLC. Now, if you wish to extend our network to a third PLC that would share information with the network, we would do the following. Read 10 registers and write 20 registers from and to the third PLC. We would then write 20 registers to the Click PLC. This includes the existing 10 plus the 10 registers from the third PLC. So each one gets an opportunity to write and then everything gets read. Click PLC configuration, Modbus TCP server. The first thing we will do is set up the Click PLC Ethernet port. You can access the COM port setting by using the main menu, Setup, COM port setup. Select port 1, Setup for Ethernet. You will notice that the Modbus protocol is already selected, so we will use the manual settings for the network address configuration. Since the Click PLC will be configured as a server or slave, ensure that the TCP port number is set to 502. This is the default port number for Modbus TCP protocol. We will leave everything else as a default. Select OK to close the COM port setup details. Select OK again to close the COM port setup. We will now find the Modbus addresses that we need from the address picker in the Click programming software. Select Address Picker under the latter program in the navigation menu. You can also get this via the main menu, Program Address Picker, or Ctrl+T. Select the DH area on the left side of the address picker edit mode. Ensure that Display Modbus Address is selected. We are using Modbus 984 addressing. Note the following. DH1 is Modbus address 424.577 and DH11 is Modbus address 424.587. Select OK to close the address picker window. More information can be obtained by going to our Click PLC series page. This will go through most of the features of this cost-effective programmable logic controller. Productivity 2000 Modbus Overview. Modbus TCP protocol through the Ethernet port or RJ45 is a method in which we can communicate to the Click PLC. This is a client or master to server slave protocol. The client sends the request and the server will respond to that request only. The Modbus TCP protocol can be viewed at the following URLs. Productivity 2000 port setup, Modbus TCP client. The Ethernet RJ45 port must be set up under the Setup in the Application Tools. Select Hardware Config. Alternatively, you can use the main menu, Setup Hardware Config. The hardware configuration window will now be displayed. Double-click on the CPU unit. This will bring up the CPU model window. Select the Ethernet port tab at the top of the screen. Our port settings will now be displayed as following. We are using a fixed or static IP address. Select OK after setting these parameters. Click X on the hardware configuration window. We are now finished setting up the Ethernet port on our PLC for communication. Productivity 2000 PLC Program. We will use the Modbus Read MRX and the Modbus Write MWX instructions for our Modbus TCP master program. Modbus Write MWX. This instruction is broken down into 3 sections. The first is the instruction parameters. Select the Ethernet port, CPU, ETH, EXT. IP address is set for 192.168.1.130, which is our Click PLC. The slave node number is set to the default of 255. Since Modbus TCP uses the IP address, this is not utilized for our instruction. We will use the structure of the name of Modbus TCP Write. This will set up the corresponding addresses and bits for this instruction. The second part is addressing and polling instructions. This makes the setting of the Modbus master the easiest I've ever seen. The automatic polling feature allows you to choose the rate at your desire to send messages without having to use separate timer and enable logic. The message queue stages the messages from the ladder code to go out to each physical communication port without requiring interlocking logic. The longer the poll time within the application's tolerance, the better the overall network performance. So for efficiency in programming and the best possible performance of the network, conservative poll rates should be used when utilizing the automatic poll feature. There is also a poll offset field in the communication instruction. This will help the instruction from being queued all at the same time. When the CPU project starts, there is a master timer that begins. The ladder scan will look to see if the instruction is enabled. If it is enabled, it will begin the automatic poll timer at the specified poll offset value from the master time clock. We will select automatic polling at 50 milliseconds. This means that all of the timing between the Modbus write and read commands will be automatically handled by the PLC firmware. Our slave Modbus starting address is 24577. Note that the plus 4000000 offset is then added to the base on the Modbus function code selected. This is the Modbus address for DH1 in the Click PLC. We will be using Modbus decimal addressing. The third part of the instruction is tag name mapping. This will specify where the information is located to be written in the Click PLC. We will create a non-array of 10 tags. Our tags will be 16-bit integers named P2000 netwrite 1 to P2000 netwrite 10. Modbus read MRX. This instruction is broken down into 3 sections as well. The first is the instruction parameters. Select the Ethernet port, CPU, ETH, EXT. IP address is set for 192.168.1.130, which is our Click PLC. The slave node number is set for the default of 255. Since Modbus TCP uses the IP address, this is not utilized for our instruction. We will use the structure for the name of Modbus TCP read. This will set up the corresponding addresses and bits for this instruction. The second part of the addressing and polling instruction, automatically polling, performs all of the sequencing, so you don't have to write any logic. We will select automatic polling at 50 milliseconds. Our poll offset will be set at 25 milliseconds. This means that when the instruction executes, a delay of 25 milliseconds will be observed before the first read takes place. Our slave Modbus starting address is 24587. Note that the plus 4000000 is added based on the Modbus function code selected. This is the Modbus address of our DH11. of our Click PLC. We will be using Modbus decimal addressing. The third part of the instruction is tag name mapping. This will specify where the information read is to be placed. We will create a non-array of 10 tags. Our tags will be 16-bit registers named Click Net Read 1 to Click Net Read 10. This will read the values of these registers from our Click and place them in the Productivity PLC. Note that the Modbus read and write instructions do not have any logic to enable them. They are enabled all the time because of the automatic polling will take care of the timing sequencing for us. Heartbeat pulse bit, ensure communication is working. The Productivity will send a pulse bit that can be used to determine if the communications are good. The pulse bit will be on and off for 1 second. The heartbeat bit will oscillate bit 1 of P2000 net write 1 on and off. Click PLC can then use this to determine if communication is functioning correctly. Here's the program for the Click PLC for the heartbeat. We take the first read area register from the Productivity and separate it into individual bits. That would be DH1 word to C1 to C16. The Productivity will pulse a bit on and off for a second. This will then set up the heartbeat to detect the communication loss. When the heartbeat bit is on or off, delay timers are started. The timers will have a set value of 2 seconds. If either timer is activated, then output Y1 will come on. This will indicate we have a communication error. Determine the throughput time of the network. The Click PLC is setting a bit on, and we are in turn setting a bit on in the Productivity PLC. The Click program will use a timer to determine the time it takes for the signal to be sent and returned on the network. The result in milliseconds is located in P2000 net read 2 register. You can see that setting up a communication network between the Productivity and any other communication is quite easily done because of this automatic polling that the Productivity series has built into the firmware of the PLC. If you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.